Hi students, this is Mr. Yao. Today we are going to continue to learn more about parabolas. Last time we have learned about parabolas that's facing up and down. Today, of course, is going to be parabolas that's facing left and right. But before we get into the lesson, let's review something we have learned before, which is completing the square to change into vertex form. So for A, in order for us to actually change it into vertex form, let me write down the vertex form first. A and then x minus h squared plus k. So that means we need to complete the square to have the square part. Of course, we also have this extra number on the end. So let's go ahead and do that. But first, we are going to take out the a, so factor out the 3 from this part and this part. Basically, divide everything by a 3 and see what's left. We're going to have an x squared and a 6x, leaving a space. That's the number we need to complete the square. And we're going to put the 26 outside the parentheses. Next, it's time to figure out what number we are going to put in that blank. Since this is 6x, 6 divided by 2 is a 3, and we are going to square it. So 3 squared is a 9. We are going to put a 9. However, that is not fully n, because if you think about it, if you open the parentheses, right now you're going to get 3x squared plus 18x plus this 27 plus 26. That's not the same as the range though, because we have added this extra number to 3 times 9, which is 27. So in order to still keep our equation the same, or in other words, keep it balanced, we are going to subtract a 27 on the end. Basically, that means whatever extra number we added, we're just going to balance it out by subtracting on the end. Now we can actually keep going. 3 and inside the parentheses is going to be the x plus, because it's a 3, plus 3 squared. On the end is 26 minus 27, which is minus 1. That is the vertex form. Now let's try B. Of x, same thing, we're going to divide the first two terms by a negative 2, basically factoring it out. So we have x squared minus 6x. Don't forget to leave a blank so that we can actually try to put a number to complete our square. We still put the minus 17 on the end. Now let's figure out what number we need. It's a negative 6, so negative 6 divided by 2 is a negative 3. But negative 3 squared is still going to be a positive 9. And in this case, let's see what extra number we actually put in. We got a negative 2 and a 9. Together is a negative 18. So we actually need to add 18 on the end to balance it out. Now let's write down the final form. It's a negative 2 in the front, and then we have a x. It's a negative 3, so x minus 3 squared plus 1 on the end. That is part B. Now moving on. In this lesson, we are going to learn about parabolas that faces left and right. This means the directrix will be a vertical line. Now, vertex at 0, 0. When x equals 1 over 4p, then y squared, or 4p y, x equals y squared. So this time it's basically saying, like, for example, x equals y squared. That is going to be facing left and right. Of course, this is a very special, it's not quite a function, it's just an equation to present a graph that is a parabola. So let's start with point P0. This time is not 0p, it is P0. Let's say it's around here, P0. That's going to be my focus. In that case, the directrix is going to be x equals negative p. Reason? Because the vertex should always be halfway between the focus and the directrix. The vertex is p away from the focus, which means it also need to be p away from the directrix. So yeah, and p is the distance from the vertex to the focus and to the directrix. Thus, the focus will always be inside the curvature. Focus right here is inside the curvature. Next, P is related to basically how wide it opens, but related to the A in our quadratic form of the parabola function. Now, we have talked about this already last time. The reason we have 4P is because right at this point, if you draw a chord that is perpendicular to the axis, that is called a focal chord. That focal chord length is 4p, basically 2p on each side. That whole thing is 4p, and that's why p is related to 1 over 4a, or a is related to 1 over 4p. Moving on. there is a mistake. I accidentally put the graph that's facing up. We actually need a graph that's facing left or right. So let me draw that real quick. We're going to ignore this. Let's say that is the one that we need. Walk a bit closer. Let's say that's the one we need. And actually, we don't even need a horizontal axis because our graph is going to be having a vertex. It's going to have a vertex of h. Okay. And this is the formula. That's the more general form. 4p times x minus h equals y minus k squared. If you think about it, compared to the things we have learned in the last lesson, all that happened was just replacing the x minus h, replacing the x minus h with y minus k, and replacing the y minus k with x minus h. They switch places. That would switch our axis, or directrix, or focus. Vertex is hk. And p is still the distance between the vertex between the vertex and the focus, and the vertex and the directrix. So let me draw my focus. The focus is actually, let's say the focus is just here. That means this portion of distance is going to be a p. I might need to actually do a bit further. Let's say our focus is actually right here. This portion is going to be p, so that means I need this portion to also be p. So my directrix would be right there. Now, if the horizontal portion, the horizontal coordinate of this point is h, that means this part is h from the y-axis. And I added on this p, then of course this point will be h plus p comma k. And again, if that is h, I'm going to the left by p to get to my directrix. Then my directrix would actually be x equals h minus p. There's a typo, it's h minus p. When p is greater than 0, it opens to the right, and when p is less than 0, it opens to the left. These are things you should be able to directly decide based on this number in front of x minus h in today's lesson, or y minus k in last lesson. Now let's have a look at a few examples. Example 1. Focus is at -2, -4, right here. Directrix is at x equals -6, right here. So based on this, since something we have established is the focus needs to be inside the curvature, the curvature will never cross the directrix. So of course this is going to be opening to the right, since the focus is actually on the right side of the directrix. And since we are talking about this, if the focus is actually on top of the directrix, that's facing up. If the focus is on the bottom of the directrix, that's facing down. So basically, we're always using the focus and the directrix, relative position of the directrix, to decide which direction is our graph opening. Now, the midpoint is where the vertex will be, because that is always going to be halfway between the focus and the directrix. So that makes our focus, our vertex, as -4, -4. Now, since we figured that out, vertex is always p away from the focus and p away from the directrix. That part is p, 2, that part is p, so that p will be 2. And I can graph my, my parabola. But before that, let's actually write down the equation. Since it is facing left and right, that means my x doesn't have a square, my y does have a square. So on the left side, 4p is going to be 8, then x minus -4 is x plus 4. On the right side is y plus 4 squared. There is my equation. Now I can graph it. I'm not going to require to graph it super precisely, but at least since we have talked about it is 4p, we would know the focal chord would actually have a length of 8, since p is 2. That means this part is a 4, and that part is another 4. That's my focal chord, so I can kind of at least graph it as precise as I can about the opening. And that's how it would be. Just like that. Okay, that's example 1. Next, example 2. My focus is -4, 0. Right here. My directrix is at x equals 4. And as you can see, my vertex is going to be halfway, which is going to be at 0, 0. Now that means it is 4 away from my focus and 4 away from my directrix. My p would actually be a 4. Vertex is going to be 0, 0. I highly recommend you actually write these information down before you try to find the equation, because they're not going to be helpful. Now it's time to write our equation. It's 4px, so 16x. The reason I'm just writing x is because the x-coordinate is a 0 for the vertex. X minus 0 is just a 0. On the right side, y minus 0 then squared is just y squared. Now to draw my graph, P is 4. That means on each side of the focal chord, we are going to have 8. So that's where the focal chord will be. Let me actually change the color. That's where the focal chord will be. And we have another 8 on the other side going down. So that's my focal chord. I can just roughly connect them. And there is my parabola for example 2. Moving on, example 3. This time we are not given a graph, so let's draw a little diagram. The diagram is typically just a vertex, a focus, and a directrix. That's kind of how it is. So let's roughly draw one. Vertex is at 0, 0. My directrix is x equals 4/3. Well, clearly that is to the right of 0, 0. So right here, x equals 4/3. As soon as we write that down, we would know our p is going to be 4/3 because x equals 4/3 is 4/3 away from 0, 0. And if you think about it, when we try to write the equation, all we need to know is the p and the vertex. So let's write it down. 4px, so 4 times 4/3 x, x minus 0 equals y minus 0, then squared. So we just have 16/3x equals y squared. That's example 3. Example 4, vertex is -4, 6. Let's say this point is -4, 6. Focus is 3/2 and 6. That is clearly to the right of it. This is my vertex, and that is my focus. I would know my graph is... Oh, there is one thing I actually forgot about. Let me actually go back to the previous example. Right after we figure out our directrix is going to be on the right side, something else we would also know is our focus is going to be on the left, which means our graph is actually opening to the left. So even though we found p is 4/3, the direction is going to be decided by the sign. So it is actually a negative 16/3x because our graph is facing left. Now let's go back to example 4. -4, 6. So that is my vertex, that's my focus. Clearly I can know it's like facing right. And if that is -4, 6, and that is 3/2, 6, we are going to need to try to find our p. Basically how far away these 2 points are from each other. So 3/2 minus a -4, that is going to be 11/2. That is my p. Now it's time to write our equation. 11/2 times the 4, that's 4p, then x minus -4. On the right side, y minus 6 squared. So we're going to have 22x plus 4 equals y minus 6 squared. In this case, again, is opening to the right, so clearly it's going to be a positive 22. That's example 4. Moving on, example 5. Based on the equation, determine the vertex, focus, directrix, and the direction for each of the parabola. So first, the number in front of x is a positive, so we would know it is opening right. Also, because it's actually in front of the x, that's why we know it's opening left or right. Since positive is opening to the right. Next, there's nothing with x or y. There's no like x minus something, x plus something, or y minus y plus something. That means my vertex will be 0, 0. And let's actually draw our 0, 0. We already know it's going to open to the right. That's kind of roughly how it is. Since this number 6 is 4p, that means my p is, let me write it on the left side. Since 4p is the 6, that means my p is going to be 3/2. So my focus would be 3/2 away. So that's 3/2 away. So I can't find my focus to be 3/2, 0. Also, my directrix is on the other side. This part is also 3/2. So my directrix would be x equals a -3/2. So you see, we're drawing a little diagram again. Even though we don't have a graph, we can kind of roughly draw it out. Next, example 6. Same thing. Let's start with our vertex and the opening. It's a positive 16. That means it's opening to the right. Also because actually x doesn't have the square, that means open left or right. Next, our vertex is going to be the opposite number that's with x and y. It's a -4, so it's a 4 for x. -6, so it's going to be a +6 for the y. Let's actually just randomly draw a point representing a 4, 6. What do you know is opening to the right? So next, let's figure out our p. 4p is going to be 16, so that means my p is going to be a 4. So my focus is going to be 4 away from my vertex. That means my focus is going to be 8, 6. Also 4 away on the other side to get to the directrix. My directrix is going to be x equals -4. That is example 6. Lastly, example 7. There's a typo in the notes. It shouldn't be 3x, it should actually be 3y, because this is going to require what we have learned, what we have reviewed in the prior knowledge. So first, we are going to need to rewrite it into the form that we want, which basically means we need to complete the square. So x equals y squared minus 3y. Then we need the number to complete the square, keep the +9 outside. Now the number that we need to complete the square is first -3 divided by 2, and then -3 divided by 2 is going to be squared, which is 9/4. So we need a 9/4, but since we have added this 9/4 for the right side of the equation, we need to balance out by subtracting a 9/4. Now the whole thing is just going to become x equals, remember we're going to use this number inside the parentheses, y minus 3/2 squared. On the end, that is 36/4 minus a 9/4, which is 27/4. Now we have our equation. We can decide our vertex first. Also, the number in front of x, well, this is kind of special because we don't see a number there. But remember, when you don't see a number, it's a 1. Since the positive, we know it's opening right. And also, we can find our vertex. There's no number attached with together with the x for adding and subtracting, so it's got to be a 0 on the horizontal x coordinate. Then the y is going to be the opposite of the given, so 3/2. Let's draw our little diagram. 0, 3/2, and it's facing right. Next, we need to find our p. Our p in this case is a bit different. Since that is 1, that means my 4p is 1, so my p would be a 1/4. So this is actually 1/4 away from our focus. That means our focus, in this case, is going to be at 1/4, 3/2. Then to the left side, of course, is our directrix, which is also 1/4 away from a vertex. So it is going to be x equals -1/4. And that is example 7, which concludes everything about this second lesson of parabola. Thank you.